later. Now, this here, simplest form, I know it's not showing up in your notes, is what we had yesterday because it was the 3 steps. Now, simplest form, I'm going to go back over these again. No radicals have perfect nth powers as factors other than 1. We're not going to leave something in there that can be simplified out. We can't leave it as a square root of 9 or the cubed root of 8. We can't leave it there. We have to get it out. We have to simplify it. No radicand can contain fractions. We can't have a fraction inside the radical. And no fraction or radical can appear in the denominator of a fraction. That's why number 1, 1 over 6 to the 1/2, 1 over the square root of 6 was not right. We had to fix it. But here's the first page that we have. Properties of radicals. And for the most part, we kind of know this, that we can split it up. If we have 2 things being multiplied inside the radical, we can break it up as 2 separate radicals. So the cubed root of 4 times the cubed root of 2 is the same as the cubed root of 8. So we can put them together, we can take them apart. Same with division. The 4th root of 126 divided by the 4th root of 2, we can rewrite as the 4th root of 126 over 2, 4th root of 81, which is 3. We can do this to simplify. We do it because we need parts that will simplify. And not everything will simplify, but most will. So if we look at this first one here, we have the cubed root of 12 times the cubed root of 18. Now I can take the calculator and say cubed root of 12. That's not a nice number. And neither is the cubed root of 18. Now we could try plugging the whole thing in and it will give us an answer, but it won't always give us a nice answer, because if it doesn't, we have to reduce this. We have to see if there is a perfect cube contained within these. And to do that, we need perfect squares. We need numbers times themselves. Because for a cubed root, we need a number times itself 3 times. Because for a cubed root and that number to simplify, we need cubics. So, well, let's go back to the time-trusted factor tree to figure out its factors. Because 12, one of the main factors that it has is 2. Because 2 times 6. 6 is 2 and 3. So we can say that 12 is 2 squared times 3, yes? So we can see why it gave us a decimal answer. Because neither one, even if one of them was a perfect cube, one of them's not, yes? So for our case in point, we could say the cubed root of 12 is the same as the cubed root of 2 squared times 3. All right, guys. Thank you. Let's look at 18. 18. Well, that is 2 times 9, and 9 is 3 times 3. So we can say that this is 2 times 3 squared. Questions on how we broke this down? Because the whole goal of this is to find perfect cubes, find perfect ways to reduce this if it is possible, and it is. And we have these here, because every group, or 3 to the third, or 2 to the third, will simplify out. It will come outside the radical. It will reduce. Questions on how we got to the cubed root of 2 squared times 3 times the cubed root of 2 times 3 squared. We good with getting here? Yes? Now, as our formula said, if we have 2 radicals with the same root, we can multiply them together, or we can split them apart. We can go in either direction. Here, we can multiply them together. In the first one, we have 2 squared. Second one, we have 2 to the first. And 2 squared times 2 to the first is 2 to the third. I can take the cubed root of 2 cubed. That will simplify nicely, yes? Okay, let's look at 3 before we simplify it. Well, in the first one, we have 3 to the first. Second one, we have 3 squared. So now we have 3 to the third. Now, what is the cubed root of 2 to the third? 2, because 2 to the third is 8. Yes. Because really, we can separate this, and I'm going to do that. That's why I left that big space, because we can say this is also 2 to the third times cubed root of 3 to the third. Just like we took the original two and put them together, we can separate them back apart. Now, it's kind of an odd step. We don't necessarily have to do this, but it does help us see. Because the cubed root of 2 to the third is 2, yes? What's the cubed root of 3 to the third? 3. So we're saying that we actually have 2 times 3, which is 'so the cubed root of 12 times the cubed root of 18 is 6. Could we have typed that in the calculator? Yeah. Now, if it doesn't simplify nicely, we're left with the cubed root of 2. Both calculators will throw it out as a decimal. They won't simplify it at all. Square roots, the 30xs likes and will do very good with and well with. Cubed roots and above, it's going to convert it to decimals every single time. It's kind of frustrating, but questions on this here? We good with this so far? Now, part of the reason we're doing this, especially simplifying this, is because there was something that simplified inside of it. We can't just leave it. B, we can't leave a radical in the bottom of a fraction, and if it simplifies, we need to simplify it. Now, we can look at this here. 4th root of 80 is a decimal. And the 4th root of 5 is a decimal. Now, we could, as we saw with the previous one, type in the 4th root of 80 over the 4th root of 5 and get 2. So it's going to be interesting to see how we get 2. Now, whenever we look at division, one of the things I would look for first is, can we divide the two numbers? Yeah. Huh? That should be a 4. Thank you. I'm going to have to fix that. One thing I glossed over. That would have made everything a lot harder if it didn't. 4th. Thank you. So, we good so far. And thank you for pointing that out. 4th. Now, since they're both to the 4th power, 80 over 5, can we divide that? Yes. One of our properties stated if we have the same root on top and bottom, I can rewrite this as 4th root of 80 over 5. Well, our simplifying rule number 3 said we can't have a radical in the bottom of the fraction. Number 2 said we can't have a fraction inside of a radical. But 80 over 5 is what? Which is 2. Well, because we're able to do that and divide it nicely, evenly, we don't have a fraction anymore. So numbers 2 and 3 with simplifying are now good. We don't have either one of those. Now we just need to make sure 1 is true and the 4th root of 16 is indeed 2, because 2 to the 4th is 16, so the 4th root of 16 is 2. So I would go to the factor trees, especially if it's not reducing nicely. Because if it doesn't reduce nicely, even after, if we had multiplied these and gave us a decimal, that means there's a number to a power that does not line up with our 3, our 3rd root. Four times 3rd root of 4 times the 3rd root of 128. Well, we could try this in a calculator and see what we get. I believe it gives us 8. So this does reduce nicely, yes? Now, according to the properties, and I still find it funny that the book does this, but the way that we would do this is we can say that this is 3 times 4, cubed root of 4 times 128. Cubed root of 512. And I did watch this and them explaining this according to the textbook, and the cubed root of 512 is 8. Cube root of 512 is 8. Because, yeah, and that's how it works. Because we're just trying to find a number times itself 3 times to get to 512. And we can do that with factor trees or different things to break this number down. Because 512 is 2 times 250, not 1. It's 2, 11, yeah, 256, which is 2 times 128, which is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4. All I did was just divide it by 2 multiple times. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the 9. Well, we're taking the cubed root of it. And we'll get to this here, but when we do this with powers, we're really dividing that power by the index. Because what I'm saying is I'm taking the cubed root of 2 to the 9th, which is same as 2 to the 9 over 3, which is our 2 to the 3rd, which is 8. That's kind of how we get it in there, because we're taking out groups of 3, and with 2 to the 9th, we can take 3 of them out, which gives us 8. Questions on this here? I would do the factor tree if it does not work nicely. Because if it doesn't work nicely, what that means is this, instead of being 9, is 10. If it's 10, we can still take 3 groups of 2 out, yes, which is our 8. But I have 1 left over, yes, which would end up being 8 times the cubed root of 2. That's where we get our decimal from. Or if we had 2 of them left over, it'd be 8 times the cubed root of 2 squared, or 4. And it'd just be that thing. Does that make sense? Okay. Now again, with the next one, the 5th root of 192 over the 5th root of 6. Do those two divide evenly? So we could do our division step. We could try plugging it in. Here we can divide it because it'd be the same as the 5th root of 196 over 6. And 192 divided by 6 is 32. And the 5th root of 32 is? By the end of this, I think we might know the powers of 2 up to a good number for a while. Any questions on this here? Cubed root of 135. Well, as it's been nice so far, I get the right one. Sound a nice number? $135. $125 would be nice. $135 is not nice. So these here are where we're going to have to fall back on the factor tree. $135. All right, guys. What's the number that goes into 135? 5. 5 goes into 135 27 times. I think I heard it, but also because, I don't know. Yeah. Sometimes I get numbers, I'll figure it out before I figure it out, if that makes sense. Because 27 would be, so as prime factorizations in these powered forms, we have 3 to the 3rd times 5, yes? Now for us, this is nice, because over here we're taking the 3rd root of 3 to the 3rd times 5. Can we take the 3rd root of 3 to the 3rd? Yeah. Exponent and index match up, which is 3. Can we take the 3rd root of 5? No, because the exponent index don't match. So it just stays the third root of 5. So the cubed root of 135 simplified is 3 times the cubed root of 5. And that's it. Does that make sense? So again, I would try it in the calculator first. Because if the calculator gives you the answer, awesome. If not, we're going to have to do something else. Now, the next one. The fifth root of 7 over fifth root of 8 is going to give you a decimal. I can tell you that right now. Partially because 7 is prime. So it doesn't simplify. And we can't divide 7 and 8. They don't divide evenly, so we can't get rid of that fraction. Now, the big issue is not so much the radical on top, it's the radical on bottom, yes? Now, we need it so that we have a number to the fifth power, yes? Well, one way we can do this, and it is possible and does work, is I can multiply the top and bottom by 8 to the fourth. I would not do this, but it is possible to do it. Because we can multiply them together, yes? 8 to the fifth root of 8 here times the fifth root of 8 to the fourth would give us the fifth root of 8 to the fifth. The 5 and 5 match up and would cancel out, yes? Can we rewrite 8 as a number to a power? 2 to the third, yes? So here, we do have the fifth root of 7, that's fine. On bottom, we have the fifth root of 2 to the third, yes? To simplify this radical, I need that exponent to match the index of the radical, yes? How many more 2's do I actually need? 2, because if I have 2 more, we have 2 to the fifth and the fifth radical, yes? Now, the way we had, and I started out, does work. 8 to the fourth. Well, really, we're saying that we have 2 to the third to the fourth. I said I only needed 2 of them, right? I actually just multiplied it by 12 of them. It will simplify out, but those extra 2 factors have to come back out in the end. Does that make sense? It'll actually give us, because it would give us the 2 to the 10th, which would be 4. We have a greatest common factor of 4 on top and bottom. That would have to simplify out later. So it does work. We just have to be careful. I'm going to erase all this. Take 2. There we go. So whenever you're doing these, and especially if they don't simplify at the beginning, check the bottom of the fraction. See if we can rewrite it as a number to a power. Here, we can rewrite 8 as 2 to the third. Now we're going to multiply it by something on top and bottom. So that fifth power will simplify out of the bottom of the fraction. Doesn't matter about the top. It has to simplify out of the bottom. Now, the number that we have on top and bottom inside the radical will be 2. Because we have to match that. Because the bottom, we need it to go from 2 to the third to 2 to the fifth. Yes? It would be 2 squared. The power that we apply on top and bottom, what we're multiplying it by, will never be bigger than the index. Will never be bigger than that index. Because then we're multiplying by too much. Does that make sense? Because when the index and the power match, it simplifies out with itself. Now the top and bottom, the bottom will be the fifth root of 2 to the fifth. Well, the fifth root of 2 to the fifth is 2. The top, well, we have the fifth root of 7 times 2 squared. Well, 7, I can't take the fifth root of. Do you think it's going to be possible to take the fifth root of our 7 times 2 squared? Well, if I can't take the fifth root of 7, can I take the fifth root of 2 squared? No. So is it possible to take the fifth root of their product? No. So the last thing we have to do is just multiply them together. 7 times 2 squared. Luckily for us, unlike most of this problem, we can type that in, which is 28. Now, as I showed you the other day, we can type these into the calculator and check the decimal, make sure the decimals match up. But that's it. Questions on this here? We feel good with these so far. I think the main ones that we need to see again are the ones that don't work out nicely, yes? Like these last two. But questions over anything we've done so far? Because really, that's it for this part. Cubed root of 500. Well, it's probably not going to work out nicely. So I'm going to go to a factor tree. What's a number that we know that is a factor of 500? Because, yeah, 5 and 100, 10 does work. I try to stick with primes just so we're not having two factors breaking out. Because 5 is prime, so 100 is 10 and 10. Yeah. So 2 and 50, 5 and 10, 2 and 5. No matter how you do it, we're just breaking it down. I try to stick to it so that it's pretty much going one way, not going two and fanning out in a V. But if we look at this here, 2's, we have it once, we have it twice. So that is 2 squared. 5, we got 1, 2, 3. So 500 is 2 squared times 5 cubed. Questions on how we got this here? We feel comfortable with these two here? Can we take the cubed root of 2 squared? No. So there's no way to take the cubed root of 2 squared. So it will stay inside, and since we know it doesn't reduce, simplify it back. So 2 squared is 4. You can leave it as 2 squared and then simplify it to 4, but either way, it stays 4. Questions? Can we simplify the cubed root of 5 cubed? And it is 5. 5 times cubed root of 4. Questions on this here? Fourth root of 19 over the fourth root of 4. Now, here, 19 doesn't divide by 4, but we can rewrite it a little bit better. And I did look at this one and what the book said. It just told us to multiply by the fourth root of 4 and then go from there. But 4, can we rewrite it as a number to a power? 2 to the second power, yes? Well, I have 2 2's. How many more do I need to get that radical to simplify? 2. I have 2. I need 2 more. So I'm going to multiply this on top and bottom by the fourth root of 2. Because the bottom of this will be the fourth root of 2 to the 4th. Oddly enough, I ran out of space, but that's fine. Because on the bottom we have the fourth root of 2 to the 4th, which is 2. Because the goal for the bottom of the fraction is to get it to be a number to a power, and that power, bless you, is divisible by whatever the index is. On top, 19 is prime. It's one of our prime numbers. Bless you. So we do have the fourth root of 19 times 2 squared. Since 19's prime, 2 squared is not going to, we're not going to be able to take a fourth root of it nicely. we can just see what that product is. 19 times 2 squared is 76. Questions on this here? Again, this is, especially these last four, have been less about doing kind of mathematical procedures and more just we're going to break it down, we're going to work with it, and get it to look nicer. And that's about it. Kind of, yeah. Questions on this here? Well, be ready for the next part. We need to write this in simplest form because we can't have a radical in the bottom of the fraction, yes? And up to this point, especially the last four, the calculators have been not helpful. Because, I mean, let's see here, I already lost the problem. 1 plus 1 over 5 plus the square root of 3. Yeah, and probably, as everything's been going, having this here is not going to give us a nice answer. It's going to give us a decimal or something like it, yes? You're good. Actually, it didn't, did it? That is the answer. The 30XS is the only one that, or out of the two calculators that you have, that will do this. Actually, that's it. Mm-hmm. You can do it in the calculator. Now, the way this works, because that is the answer. I don't know how I just pulled that off. But I'm going to show you this here. The way that we actually solve these by hand is we take the conjugate of the bottom of the fraction. 5 plus the square root of 3. Its conjugate is 5 minus the square root of 3. Multiplied on top and bottom by its conjugate. Now the top of this one's nice because we're multiplying it by 1. 5 minus the square root of 3. The calculator gave us that same thing, just had it flipped. Negative square root of 3 plus 5. Now the bottom we distribute. 5 times 5 is 25. 5 times negative square root of 3 is negative 5 square root of 3. Square root of 3 times 5 is plus 5 square root of 3. And square root of 3 times negative square root of 3 is negative square root of 3 squared, or negative square root of 9. Just 3, because they cancel each other out. Now, you might be saying at this point, well, we're supposed to be getting rid of radicals out of the bottom of the fraction. Yes, they do. Because negative 5 square root of 3 and positive 5 square root of 3 are gone. 55 minus 3 is, which is exactly what the calculator gave us. The only way it won't give us that is if the numbers get too big, but no matter which ones I do, it's pretty much gave us the answers. So questions on this here? Oh. Yeah, even this one, the calculator will do it for us. And that's it. Mini